Hello everyone and welcome to our first YEA Big Physics Problem lecture. And so, basically in these videos I'll just be explaining the week's physics problem. And so we start our first week with this problem, which has to do with thermodynamics. So basically the problem is we have this wall with 4 layers and it gives us some of the thermal conductivities, which might be something you might not know, but I'll explain later. And also gives us some of the layer thicknesses and the temperatures. It tells us that the energy transfer through the wall is steady, and so it asks what is the interface temperature T34 between the third and fourth layers. Okay, so if you haven't studied thermodynamics before, this problem might seem a little daunting, but if you have, then it's probably really easy and you've already solved it. So yeah, basically in this video I'll just explain like the formula you need for this heat transfer, for like heat transfer problems, and you can just apply the formula and it'll be really easy. So yeah, this first week won't be a hard problem, unlike next week's. Okay, so basically, okay, if we have a slab here, and this side is hot with a temperature of TH, and this side is cold with a temperature of TC, then heat is going to be transferred across. And so, what is the rate of the energy transfer through this slab? Well, it's the formula is determined experimentally, and it turns out it's this. The rate of energy transfer is just the power, and so power conducted through the slab is equal to Ka times Th minus Tc over L. And so K is something called the thermal conductivity, which you might have noticed in the problem statement. And K is determined by what material this slab is. And TH and TC are already shown here. A is the surface area, like this area of the slab, and L is this length. And intuitively, you can see that the longer this L is, like as in the thicker the slab is, the lower the rate of energy transfer should be, because it has to take a longer path to get through the wall. And you can also see intuitively that the larger A is, the more energy should be transferred through, because there's more area for it to go through. So this A over L part makes sense. Okay, so yeah, so now we can literally just apply this formula to the problem. It tells us that the energy transfer through the wall is steady, which means that through each of these slabs, this P is always the same. So in fact, the problem writer is not telling us L, like K3, K2 or L2 doesn't really matter. And this is because we can just compare the transfer through L4 with the transfer through L1. So this P for the fourth layer is obviously just K4 times A times T34 minus T4 over L4. And this is equal to K1 times A T1 minus T2 over L1. And this A is obviously the same, because like they're sharing the surface, so A cancels. And yeah, so now we can multiply both sides by L4 over K4, and we get T34 minus T4 is equal to the L4 over K4 cancels here, and for here will be K1 L4 over K4 L1, T1 minus T2. So now we just add T4 to both sides, and we get T34 is equal to this plus T4. And so now we can just plug in the numbers. It tells us that T4 is negative 10 degrees Celsius. And just a reminder that the SI units are Kelvin, and you normally would convert to Kelvin, but in this case we're dealing with Celsius everywhere, so it doesn't matter. And we want the answer in Celsius. So this plus K1, it tells us is 0.06 watts per K. Times L4, it tells us is 3.5 centimeters, yeah, over 0.12, which is K4, times L1 is 1.5 centimeters, I believe. Yeah. And then, of course, times T1 minus T2, which is 30 minus 25 is just 5 degrees Celsius. And so now you can just plug this into a calculator or do it in your head, whatever you want, and you end up with the answer of negative 4.17 degrees Celsius. So that's the answer. So yeah, that's the answer. The interface temperature between the third and fourth layers is negative 4.17 degrees Celsius. And so all in all, it's a pretty straightforward problem. But if you like know all these formulas, but it's just a good introduction to like the concept of like heat transfer and thermodynamics. So yeah, we started off with a pretty easy problem today, but the next one will be useful. So just like prepare to do a harder and more interesting problem next time. And so yeah, that's it for our first lecture. And thank you everyone for listening. And hopefully, I'll see you next week for the next problem. Bye.